My name is Levi Junkert. I work for a company called SmithRx. Currently, we are working in the prescription benefit management market. I'll give you a little more information on that here in the introductions. Once we get done with the introductions, I'll go over a couple intros to HIPAA regulations, what exactly we are regulated by in this industry, and how to deal with PHI and PII, which is personal health information and personally identifiable information. This type of data, we need to make sure we protect it for healthcare reasons. I'll also be going through our solution that we built at SmithRx called the Gonymizer. I've heard other names, Gonymizer, a whole bunch of different ways you can pronounce it. Doesn't matter to me. Gonymizer is usually what I call it. So this is a really cool tool that we did open source. It is available on GitHub. I'll have all the information at the end of the talk if you want to contribute or give it a shot on your own data set. So I'll also be going over how we implemented Gonymizer in our Kubernetes environment as well. And this actually reloads on a daily basis in our development and staging environments. So we have a new data set every day for our developers to work on. I'll also go through a quick demo just on the console on how to get Gonymizer up and going. And we'll run it on a data set, and then we'll just go ahead and do a wrap up. So first of all, who am I? My name is Levi Junkert. I've been working with database systems for about 18 years now. MySQL being the primary one that I had up until about 4 or 5 years ago, until I got into the healthcare space. In the healthcare space, it seems like Postgres is a lot more active, mostly because of, I think, some of the Oracle background that a lot of the healthcare companies use as well. I've also been building software for about 11 years now, ever since I got out of grad school. Some of the software I've built is at Facebook, right now, OpenDNS. And then my first company I got into that was healthcare is called Get Better. The company is now defunct, unfortunately, and that's why I'm at Smith, building new tools for them instead. So first of all, what is a prescription benefit management company? The reason I chose to show this slide is because there's way too many arrows on it. Trying to figure out the prescription healthcare space is really, really difficult. And figuring out exactly where we fit, I try to think of it a lot simpler of, if you go to the pharmacy and you get your prescription, we're the ones that make sure that you get the right prescription for the right cost. And then we handle taking that, the prescription that you just bought, we handle taking care of that with your insurance provider. So we kind of sit in there as the middleman to make sure you're getting the right prescription for the right cost. So first, let's go over some basic HIPAA regulations. If you think about how much data we can store on our laptops today, if you actually have a production data set on your laptop and it's unencrypted, this could be a huge issue and a huge violation for your company. In fact, this has happened in the past, actually most recently in Alameda in California. Thieves were actually going into Starbucks locations and snatching laptops out of people's hands directly in the coffee shop, which just amazes me. So just holding this data at rest on your laptop for a smaller startup company like we are dealing with health information, we want to have a way to keep that data anonymized on everybody's laptop or wherever this data is, so we don't have this risk of someone coming in and stealing the laptop from us and then having to deal with getting that patient data back or having to deal with the fines that come along with it. The penalties are really, really expensive. In fact, I think this tier just changed recently. They just dropped the costs just a little bit on some of the fines that can actually happen. I mean, for example, let's say one record gets out there and it's a Hollywood star. I mean, this could be, in the 4th tier level, which would completely take us out as SmithRx as a startup company. That type of fine, there's no way we would be able to hold a $1.5 million fine. And usually when someone gets a record or steals something from a database, it's not just one record. It's usually a lot of records from the database, if not the whole data set itself. So this can be very expensive and can actually take the company down. So what does HIPAA say about possible solutions to dealing with this type of data? So if you look into the law, it gives us 2 different methods here. You can go with the expert method, which usually involves hiring a mathematician who will actually go through your data that you have anonymized and figures out a statistical exact number of how hard it is for someone to try to reconstruct the data back to the original person. So in our case, this would be, we anonymize all the data. If someone actually got the prescription, could they figure out who that prescription actually was for? And this would involve someone going through and looking at the probability of being able to pull this back together. The other method, which is also called the safe harbor method, which is a method in which we take these 18 identifiers, which they actually list for us in the law itself. We take these identifiers and we anonymize them or scramble them. And then we can actually combine that with the expert determination to figure out what the statistical advantage is, and then we can actually really protect ourselves as a company from having these large fines that could happen in the case of a data breach or a data leak in our staging or our development environment. So for the safe harbor method, I put something B2 because it's really hard to remember the actual law and the different numbers and all that stuff, but it's definitely the lawyer speak that goes back and forth in some of the meetings I've been in. So it's really important to remember just that it's the safe harbor method. These are the methods. I actually pulled this off of the University of California website, and this is the list that we actually go through on the SmithRx database, and we make sure to anonymize each one of these. The way we originally did it, I went ahead and just scrambled the names to just be random letters and numbers. That ended up being complex for some of the engineers, so now we use some libraries that actually fill in the data with fake names, etc. And I'll go ahead and show you guys that later when we go through the demo. So this is why we built Gonymizer, because it's real easy to make computer applications that can do this job for us and then automate it. So here's an example of the original data that we have. So this is me, and this is one of my records in the SmithRx database. If you notice here, we're using UUIDs as the primary key for these tables, which makes anonymizing a little bit different down the road, which I'll explain. So really what we need to do is we need to find some method to take each one of these records in here, like the name, for example, and the address, and anonymize them so they are completely different and you cannot tell that it was me as the original record. And this is where Gonymizer comes in. The other requirement that we have is we have to be able to take the original PHI data set, somehow anonymize it, and then put it somewhere so we can also use it in other database systems. So what we did is we went ahead and built a set of requirements for the application itself. And some of the basic ones show up. I'm sure you guys are noticing this already. There's a dump and a load, and a lot of the similar functionality that comes with PG dump and some of the other tools with Postgres. So what we did is we built a part of this code to separate it into dumping, loading, scrambling, the actual fields. And then also we noticed when we were doing this, we have to have some kind of map to let us know which columns need to be anonymized. So I'll go through that as well, which is also a function that we built. And then we also must keep the relationships intact. This tool would be completely useless if we had no way to handle primary keys and foreign keys, and being able to handle the relationship between tables in our data set. We also need to make sure that this process can be automated easily so we can run it on a daily basis to help that statistical advantage, or statistical number be to our advantage. So here's the different commands that we did end up coming up with. This is very obvious in the help section of the software. If you just type --help, you'll notice that we have 4 commands here. We have the dump command that dumps the SQL to a file, and then we also have the map command. This command isn't used very often once you get into production and you've already mapped your data, but it is very useful at the beginning or during any type of schema change that you will go through. And this is just keeping that map file consistent with what your data looks like and how you're going to want to anonymize your data. And then the process is really the heavy lifting piece. The process command will actually go through the data set that you just downloaded using the dump command and anonymize each individual column dependent upon your map file that you built using the map command. And then finally, at the very end, we take this anonymized data set and then we load it into another database server somewhere. So here's an example of the dump command. So we actually just wrap pg dump using Go, and I'm sorry I forgot to mention that. This application, if you weren't able to tell by the name, the application's all written in Go. So what we did is we went ahead and wrapped the pg dump command using Gonymizer. And what it does, it actually goes out to a remote server, you set it up, and it will go ahead and download your dump file for you. The one thing that's interesting, or one thing to remember about this file, and the reason why I put it red here, is this file will contain your PHI data. So wherever you run Gonymizer to dump or download your data, make sure you're doing it on an encrypted drive. You're doing it somewhere really safe. In our case, which I'll show later, I actually do this in a container that gets thrown away. So just remember to keep that in a safe location. Sure.
I like your little icons. Is that the Gonymizer icon?
It is.
Okay.
Yeah, I decided to just take the Gopher and anonymize them in a little bit of a different way. So that's the logo for Gonymizer, yes. And then also in the load command, what we do is we actually take the anonymized data, and then we just use PSQL-F to load this data into the new database file. There is some tricks that I also added into Gonymizer. One good example is a row counts file. So when you download and do your dump process, I keep track of all of the different row counts in your database. So that way, when you go into the load step, you know that you loaded all of your data correctly. That was one little infrastructure change I added at the end to easily be able to tell if we successfully imported the anonymized data set. So the process command actually does not connect to any of the servers. It doesn't need to because it already has the PHI dump SQL file, and it also has your map file, which was created by the map command here in the lower right. What it does, it takes these two files, uses the map file to say, okay, well, this column needs to be anonymized, and then we'll anonymize that column dependent upon what processor you tell it to anonymize with. For example, let's say you're dealing with addresses and you have an address column. We have a fake address processor that you can add into the map file that'll actually just put in fake addresses. The other thing that's cool is the library I used for this allows you to create your own fake addresses if you wanted to. The addresses I have loaded right now are mostly UK addresses, just so our engineers know that they're not real American addresses. So we did add some things in there to make sure that they know that it is truly anonymized data. So now that we've kind of gone through the design, now let's go back to this original record and how do we go about mapping this data using the map file. It got really interesting when it came to relationships and how to keep these relationships together between multiple tables. As you can see here in the top one, the ID, the 8EBC, you notice that's over also in the claim table. So we got to keep that relationship somehow. And what we decided to do is we created a specific processor that's called the UUID processor. And what it does is it actually creates a giant hash map in memory and keeps track of what was the old UUID and what's the new UUID that I'm going to use to map this data back and forth. And with this tool, then what we can do is now we can actually map in the new claim table that is anonymized by using this new UUID that's given. So a claim's probably not going to just have the person ID. We're also going to have the doctor for the claim. We're going to have the claim details. There's going to be a lot of information in the claim table itself. But what we do is we just go ahead and put those UUIDs into this hash map, and then every time it sees this UUID when it's processing the dump file, it will go ahead and replace that UUID with the new one. This will keep our relationships intact as we go through the database and anonymize it. This is what a map file looks like. I prefer to work in JSON. YAML and TOML seem to be a little more not constructive, I guess, to me. So I decided to do the configuration in JSON. And this is what a map file looks like. So let's go over a couple things here. At the top, we have the DB name. That's where you'll define which database you're going to be anonymizing. Your seed value here. This is really useful for whenever you're doing any type of debug inside Gonymizer itself or changing or adding new processors. If you set the same seed file, you're going to get the same randomized data every time you run the application. There is an option also when you're processing to say, give me a random number from the operating system. And that's the one I usually prefer, especially for anonymizing any of the data that's coming from production and then going into development or staging. Is I go ahead and let the operating system give me that number. So there is a flag there that you can use. And then below that, you see the column maps. And this is where all of the columns will be listed that are inside your database. So when you run the map command for the first time, this file is going to be huge, depending on how big your database is. And it's kind of cumbersome to go through it and set it up. So the way I built the map file is that you can have an inclusive or an exclusive map file. The inclusive one should have all of the columns in your database. And it should be easy to just copy and paste those into another file that's exclusive that just lists the columns that you want to process. In that case, Gonymizer, whenever it comes across a column that's in your database that is not inside the map file, it just leaves it as is and keeps going. So this does put it back on the infrastructure engineer or the programmer that's dealing with the PHI data. You're going to want to make sure you do check all of your columns afterwards, after you've actually anonymized it, to make sure your data is truly anonymized. Everybody's schema is different, so it's really hard to build any kind of automated tool that can really handle that for you and let you know that, oh, wait a second here, we popped up some PHI data over here. So it's always a good idea to check. So as I was explaining earlier, the random UUID that I have squared out here, that is the name of the processor. And there's a list of these on the Gonymizer site, the ones that I've already built that are built in. This is very extendable and easy to add new randomizers to it, depending on what your data set looks like. Ours had mostly basic things like first name, last name, etc. So those ones are already provided, and I will go ahead and show you guys that after or during the demo. So I'm sure other people are not using the UUID functionality in Postgres. And we did run into some classic tables that were just using auto-incrementing counters for our primary keys. So creating the mapping situation here was a little bit different, but somewhat the same. What I did again was create a hash map that actually keeps inside the key the name of the schema, the table, and the column. And then what I do is I just parse on those dots and split it apart to figure out what the original number was and what the new number is going to be for the anonymized value. The one downside to this, though, is your random number generator is going to give you numbers in the millions of range. So just to let you know, just remember that your auto-incrementing counter, you have to reset that to a really high value if you plan to start inserting data into these tables or grabbing the max value from that table. You're also going to get sparse data throughout this table, since the auto-incrementing counters will be all over the place. So you just need to make sure that you do handle that after using that on one of these classic style relationship mapping. Now, this processor is not used, this is not globally for all processors. There's only one processor I built this into, and that was probably our main original processor, which was called the alphanumeric scrambler. And that's exactly what it is it goes through, for example, let's say we have a string of 8 characters. It will go through that string, and if there's a capital letter, it'll flip that capital letter to some other capital letter in the alphabet, and then do the same for lowercase or any other number inside that string. So it keeps the case the same, and also keeps numbers, numbers, and keeps letters, letters. So what I did is I added it to the alphanumeric scrambler to do the mapping for the IDs. And then what I do here is I need to set the parent schema, the parent table, and the parent column. And you can see that right here in the second part where I am where I'm working on the claim table. And that's to let the processor know that, wait a second here, this ID that I'm going to be switching to in this table needs to be one that's looked up in the hash map. And it will go back and go ahead and do that. So here's an example of our environment that we currently have at SmithRx. We are using Kubernetes, and we're using it in a production environment, a staging environment, and our development environment. And each one of these environments, they're actually VPCs that are completely separated from each other. So there is no way to get from production into staging or vice versa. So we have to keep things very, very separated from each other in case one of the VPCs is attacked and someone's able to get into it, we can shut it down quickly and not affect the other VPCs. So the way we built Gonymizer to deal with this is we added to the dump process the ability to upload the dump file. Actually, sorry, that's the processing step. I'll get to that in a second. So what we actually do is we open up a Docker container for the dump process, and then we go ahead and dump the PHI dump file from our production RDS instance. And in this case, it's running inside the Docker container, And inside that Docker container, we also include our map file. So anytime we do any type of schema change or anything like that, we add a new map file to our Docker image. That way, when Kubernetes loads it, it knows exactly which map file to use. And that way, it's dynamic, and we can change the map file outside of the automated process. So now that we have the map file and we're running in our production environment, we just pull the PHI dump file, and we just leave it there inside the container. And then once the dump process finishes, we kick off a process real quick to actually do the processing step of taking the PHI data to making it anonymized. And since we have the map file, like I was saying, already in our Docker container, we just go ahead and do that comparison. And then we go ahead and once the anonymized file is built, we go ahead and put that anonymized file into S3. And once it's in S3, then we can load it into our other environments. So that functionality is also in the load command as well, where you can use an S3 path to actually grab your file that you would like to load into staging, development, etc. The other thing that's really nice about this file that I came to find out later, some of our developers had access to the S3 bucket. I didn't even know it, and they've been using this instead to develop on their laptop. The one downside to that is the data set as it grows. I did notice that some of them are starting to move back to using staging and development. But when the file's small enough, it is really handy to develop quickly and pull this back to your laptop. And then you're not into that, that slide that I showed earlier with someone jacking their laptop. You're not having to worry about that case, which was really powerful for some of our early developers that were developing a lot from their laptops and traveling. So here's a demo. Hopefully this goes smoothly. I've had some demos in the past that do not go so well. I sure did, didn't I? So the first thing we want to do is just create the databases. The database that I've used here is the Dell Store 2. I'm not sure if any of you are familiar with it, but it's a freely available online test database that you can use and load into Postgres or MySQL. So what I did there is I just created a couple databases. I created our store and our store anonymized. So we're going to, let's see here, let's load the Dell Store into our store database. See how it copied in all of our tables. Let's go ahead and go through the configuration real quick. So Gonymizer, I used a library that's called Viper. And with Viper, you're able to actually build your own configuration files using JSON, YAML, or TOML. Or you can just use CLI flags. The reason why I decided to go with a configuration interface like this is the amount of switches and flags I was adding to the application got to be too many to handle on the command line. It just became messy and kind of ugly. So I decided to go with a different method here of being able to build a configuration file, and then I can store that inside Git, etc., somewhere where it's safe and able to be changed by other people. So you can see here where our commands are: dump, map, process, and loads actually down here at the bottom that you can't quite see. And here I actually define the database that I'd like to dump from, if I want to use SSL or not. There's also the choice to exclude schemas and also exclude tables and exclude table data. That is definitely useful if you have any type of table that has PHI in it, and you do not want to have to bring it across to your anonymized data. You can go ahead and just add those to the exclude tables flag. And these flags are actually directly from pgdump. They're just pass-throughs to the pgdump command. And that's also extendable and pretty easy to add if there is any other commands. Definitely throw up a task for me on GitHub, and I'll get to it to add some features to it for that. As you can look through our map command here, the only thing that's really different is our map file is where we want to store our map file from the original production database. So every time you run map, it's going to connect to whatever server you put here. But really what we do is we always use our production server that we want to map from, because we always want to map from something that has a consistent schema that we want to use. And this is a little bit different than going from development to staging to production when you're pushing code. The way our environment now works is we actually push our schema changes to production, and then we pull the data back to staging and pull it back to development. And that's just because the data has to be anonymized before we can actually do any kind of schema changes to it. Okay. So let's go ahead and give it a shot here with the process command. Actually, we have to dump it first. So let's do, so let's load the config file. So it's asking me for password. I don't have a password. I also have it set up in debug mode, so you're going to get a lot more information when you are in debug. When we're in production, we usually put it in info mode, and you do not see a lot of the debug statements that you see here. So you can see right there it ran pgdump, and with pgdump you can see the exact command that it ran on the database when it was actually extracting the information. This is really useful when you're debugging or if you're trying to figure out why your data didn't get into the dump, etc. So let's go ahead and do a process step now. I actually did the map step before. Did any of you want to see the map file before I move forward and run the process step? Yeah, you want to see that real quick? Okay. So as I showed you all earlier, here's the DB name, the schema prefix, etc., the seed, all the information that the map command would have built originally. So what I did is I went ahead and ran the map command originally, and then I copy and pasted which columns I wanted to actually de-identify or process. And right here you can see I'm using the identity scrambler, which means leave this column alone. I'm not going to edit anything in this column. So you can always add that back in if you want to, or you could just remove this column and it should just go away and we shouldn't have it in there and it won't affect it. Here's an example of the fake first name processor. So here we will actually get a random fake name from the faker library that will put in a fake first name. And you can guess that fake last name, fake street address, all these are listed on the website that you can go to and look at, and they're really, really useful. So let's go ahead and try doing the process command. Okay, and what you can see here actually is the process command is going through each individual table and anonymizing specific columns. You can see here where it was doing the customer ID column. And then we were also doing the customer table, which had a whole bunch of different PHI columns in it. One would be like the first name, last name, address, state, zip, etc. So what I did is I went through the map file, added all of them, set them up with the correct processors. And now that I ran process, we should have some data that's been processed properly. But before we go through the data, let's go ahead and load it first. It's a lot easier to test this in SQL than it is through looking through text files.
I may have, go ahead.
Oh, quick question. How does this data, what is the source of data? Like if I have the first names, right? So we need to, if we want to have the, the amount of first names, distinct first names is pretty large.
Yeah.
So if we want one-to-one mapping, we'll need to pre-generate this or
Yes.
have a dictionary?
So the library that I included in this in the project itself has a list that's already built into the library.
So this is Faker, right?
It's Faker, exactly. Yep. This is built on the original Ruby Faker application or library, just that this is the Go version of it. The other thing that's nice about the Go version of it is you can replace that list with whatever you want inside the library itself.
But what if we have, let's say, 500,000 distinct streams of
Mhm.
first name? It's not a valid example, but let's imagine that. The faker should have 500,000 distinct streams to that.
Mhm.
Do you pre-generate them, or you generate them on the fly?
They're pre-generated by the library itself, and it keeps them in a text file in the library.
But as far as I know about the faker, faker has a limited number of distinct. So if I have, let's say, a very large number of distinct first names
Mhm.
in the source database, will it overlap sometime?
Yes, so it will actually, what it does is it actually grabs random from that list. So it doesn't assume that you've used that one and then throws it away. So you can overlap and use the same first name more than once.
In the same with the last name, right? So
Yes.
one last name can be associated with the two different last names.
Correct.
So that means that if we have a mapping, something like client visit, and we
Mhm.
store their the first name, last name, and then we have client claim
Mhm.
stored there as well. Then we will have a different first name and different first name in two different tables. So it
Yes.
will not be that's
Yes, that is correct. And we did notice that when we were doing that with our doctors table. Our doctors table would get different names in it, and then this person, you go look back at their claim, and you'd notice that their claims all came from different doctors, but really in the real world, it probably wasn't different doctors, it was all the same doctor. And the reason why we didn't care about that mapping is, in a way, it made it more anonymous for us, which was better. So just not being able to keep those names mapped to each other was better. There is a way in which you can add that to Faker by building your own processor and then just keeping a map of the last names to first names or the IDs in the actual tables themselves. And that is possible through, I think the alphanumeric scrambler might be able to do that for you. The only thing is the alphanumeric scrambler does not actually put in real names. It'll actually just be like random letters inside that name. So I think we could actually add that functionality to the last name Faker, for example. But there is the ability to do that. And I separated those processors out to make it real simple for anybody to want to add their own processors. Go ahead.
I may have not been listening well enough, but is the anonymization component reading and generating a SQL dump file, or is it going to the database and making the changes in the database on those particular fields?
We're actually changing the data in the dump file itself. During the processing step, we actually have two file pointers open. We have the one from the original PHI data, and then we have the file pointer for the anonymized data. And what we do is when we hit that column in the dump file, and it's really nice how Postgres set up the dump files as far as you can just do the copy command. And that's what we're doing is we just tab separated in the columns. And then once we hit that column, we look up the map file and change it in the new file.
Okay, thanks.
Mm-hmm.
So what are all these PSQL commands then?
So which ones are you looking at right here that you're curious about?
Here, running command, PSQL, etc.
Let's see here. So what we're doing is we're actually, when I load the database, this was a safety feature. This is actually the next piece I was going to go through.
Oh, okay.
So in the load step, I added this as a feature. I learned this at Facebook. Always load into a temporary database and then switch them underneath once you get the data actually loaded. So that's what I'm doing here is I'm creating a new database that's called _loading. I load the data, the new anonymized data into that loading database. And then I take the old anonymized database and rename it to a timestamp at the end. And then I take the new anonymized database and put it in place where the old one was. And I'm just like atomically flipping this underneath as the application's still running. And this allows me to change the data as developers are still working on it. Any other questions? Cool. I think that's it for the demo part. Let's see here. Just had a couple other things here. I did want to go through that we are hiring, and we're definitely looking for some new software engineers and product managers. Our company is growing really quickly right now. We're based out of San Francisco, though, and I think we do allow remote as well. So if you're interested, please let me know after this, or shoot me an email, or shoot recruiting an email. I'm also asking for contributors for people to help. If anyone's looking to help, please get a hold of me online or through the GitHub page. Yeah.
question. Do you support or plan to support MySQL?
That was one of the reasons I did the call for contributors. I'd love to get MySQL supported, but unfortunately I don't have the time to build the MySQL support yet. I think this would be a very useful tool that would work. If it worked on both database systems, I think that would be great.
Right, because
Yep.
it gets the dump anyway, right? So it will work with the dump. So let me ask you this. Was it a specific reason that the source is actually a dump and not CSV file? Because CSV file will be more supported by any system.
Some of it had to do with some of our legacy functions that we had built into Postgres, and we had to transfer the functions as well. So it's like keeping them in separate files, it just didn't make sense to do it that way. So we just decided to use SQL files instead. That way we could add the functions back in later. And the other thing that's nice too is that the load command, you do have the option of adding like for example, accounts. Like the accounts to get into our application, those all get blown away. So we need to have some way to add those back in. But yeah, it would be great to have MySQL support as well. Yeah. Sure.
What do you find are the practical limits on the size? Like with my database,
Mhm.
a PG dump just won't finish.
Yeah.
I give it a couple weeks and then I give up.
Yeah.
So,
Unf-
and it looks like you can just, grab certain tables basically.
Yep.
Whether you include or exclude. So that's handy. But what have you found, with health data? I imagine it's not small.
Yeah.
So what kind of sizes are you seeing to be practical as far as quantity of rows in a table? Or
Yeah.
things like that.
The biggest that I've worked with so far is I think it's about 38 gigs by the time I get done doing the dump. So it's still small. It's small enough to work with on a Docker container. The process step is rather quick. We are using AWS, and we do have it on a bigger machine when it is running in Kubernetes. And I think that file takes maybe around 45 minutes, if I remember right, to anonymize the whole thing. It's pretty quick, but I haven't yet used this on a huge data set. So I'm not sure what the limitations quite are going to be once we get to bigger data sets.
Yeah, it seems like looking at the directory dump format might be the way to go.
Oh, okay.
Because then you could actually do parallel processing of the various tables.
Okay.
The hitch with that is the dependency tree,
Yeah.
right?
Yep.
Doing parallel processing of the tables, you need to make sure that the ID is being remapped.
Mm-hmm.
Well, no, maybe you don't. It would be a race condition problem, right?
Yes, correct.
Is that you have two different parallel processors encountering the same ID at the same time. Which one,
Yep.
you'd have to have explicit locking over the mapping table.
Yes. I've thought about this as well, as how can I get this to be parallel processed? Because right now it is a single process. And I was thinking separate it at the table level as far as each individual
Yeah.
table. And then, yeah.
Yeah, but just locking the mapping table wouldn't be terrible. It would certainly be faster than doing it all in a single stream.
Yep.
One of the things I was going to ask you is, have you looked at integrating this with any kind of a sampling thing, right? Because often for dev, you want a database that's 1% of the size of a production database.
Yeah. Yeah. I actually have not looked into that. I was planning on looking into that once our database got big enough. So I just haven't hit that issue yet in production to add that yet. But yeah, these are all pieces that I'd love to add to the project. Yeah.
Another question is, what we are currently doing is we're doing it inside of the database. So instead of dumping, because in our case, the dump itself in MySQL doesn't matter.
Mhm.
The restore part will take 3 hours,
Yep.
right? So just the restore. So what we are currently doing is trying to do is to map. So we built dictionary first.
Mm-hmm.
For the first name, last name, address, and stuff like that, build a distinct, basically, a distinct dictionary with a hash.
Okay.
Then we have pre-generated the faker data based on Python
Mm-hmm.
faker, and then we can map one-to-one. So actually, it's not 100% faker data. I have generated the random.
Yeah.
Everything. So then we have, and then in a single query, I can exchange the first name using this dictionary to the faker data. So faker data has auto increment primary key,
Yeah.
which I don't know how to map to Postgres, but sequence probably, right?
Mm-hmm.
So then we have the same sequence in the dictionary. And with that, it doesn't matter which ID maps to which ID, as long as it's consistent.
Exactly. Yeah.
So, and we just do this insert select. So we create a new database like you do.
Yep.
And then we create a schema in this database. And then we just do it insert select. It is a little bit less configurable, but you're doing it through the hash map.
Yep. Yep.
Which is not, this is similar to what
Yeah. Just so I'm not doing it in a table, which it sounds like you're doing it in a table, right?
We're doing it in a table. So
Yeah.
to
Yeah.
back
Yep.
because of the database size.
Mhm.
What do you think about have you think about doing it inside of the podcast?
So I had that original, like when I first was handed this, I was given this project by someone else who actually did the original design. And he designed it from the ground up to do the database files. My plan was once I got to the point where the database was falling over and I was going to have to do it that way, I was going to put it back in the database. But yeah, in the beginning, he built it with the dump file, so I just continued to work with that way. And it does really good with these smaller databases. Don't get me wrong, but it's definitely, it's not, I can already see the scaling issues that are going to come from this, working outside the database and then also working with larger databases, and the processing step would never finish if it was just one processor.
Another interesting project that I recently came along is called ClickHouse. Obfuscator, I think that's.
Obfuscator, yeah, I think I've heard of that one.
Yeah,
Yep.
so they are working with the delimited files.
Okay.
So you can export into delimited files, and it's written in C,
Mhm.
and it will basically, based on the configuration, it will find the field and change it to random, and it will generate it.
Oh, okay, interesting. And this is for delimited files then.
Or delimited files.
Okay.
Right.
So you could do CSV in that step,
Yes,
in
yes,
that case
yes,
then, or
yeah,
tab or
yeah,
something
yeah.
like that. Okay, that's pretty cool. Nice. Cool. Any other questions? This is my first real project with Postgres, and it was really fun actually to work with a different database system after working with MySQL for a long time. So,
Nicely done.
thank you. Thank you.
Yeah.
Cool. Thank you.
I'm gonna say there's some limitations with this if you're supporting analytics applications.
Yep.
Because the problems with the anonymization process is gonna change the distribution of the data.
Mm-hmm. Yeah. Well, yeah. Big time.
When I was at Mozilla, we went to a lot of trouble to do an anonymization thing that kept the distribution of the data the same.
Interesting.
But that had to be highly specific to the database
Yeah,
you're doing
yeah,
it on, right?
Yeah.
Because otherwise you end up with data where you could actually reconstruct the original relationships.
Yep.
If you're sufficiently clever. It was just that it was an analytics application. We had a lot of data that was distributed in a very exponential curve way.
Yep.
And if we didn't maintain that exponential curve, then we couldn't use it for valid testing.
Oh, okay.
Because like one of the performance problems we run into all the time is somebody would query one of those values that only shows up 0.001%
Yeah,
of the
yeah.
time, and it would
It's
blow
just
all
edge
the query
cases, yeah.
plans. Yeah, and if we didn't have that kind of data in the test database, we would never see that.
Yep.
We had that problem we actually currently had before with the development cycle, with a different distribution of the first names or last names. We see a different query plans when the developers will
Oh, yeah.
test. So you do explain, and then you see a completely different query plan.
Well,
Because
but the thing is,
of-
ultimately, right, if somebody's filtering for a value that appears to 1% of the time,
Mm-hmm.
Yeah.
versus filtering a value that appears 10% of the time,
Yeah, exactly.
you want a different query plan.
Right, exactly. But because we're changing the native distribution in
Right.
the production system
Yeah.
to something that has much more, much less cardinality.
Yeah. Yeah.
That's problematic.
Yeah.
I have another question actually.
Sure.
What do you do with the fields which natively have low cardinality, like gender? Or
Gender's an interesting one. So we do use Faker for gender. That's a tough one, considering you only have two choices.
Exactly.
So sometimes the Faker will just change it back to the same thing. But it depends. In the medical industry, and depending on where it is, with insurance companies that we've been dealing with, unfortunately, they only have two that we can pick, and that's what we do for that Faker. Yeah.
So what we do is we just do a generate random
Yeah.
value, not using a faker at all.
Yeah.
Just generate the random value.
Okay, I see.
think that's the best we can do here.
So we do. There is another one that insurance companies use as well, which is person code, which is who is this in the family? Is it a dependent? Is it a partner? So it's a very low cardinality as well. And what we do is we usually choose a random number for those as well. Yep. Any other questions? Cool. Awesome. Thank you very much.